Hello and welcome back to the lectures on applied econometrics, and we are in module 2, and in this lecture we are going to talk about adjusted R square. So, we are talking about different terms associated with a regression equation and regression table, the way we understand it, and it is something that is important for penalizing if we have number of different variables which are irrelevant in regression equation, and we are going to just see that how adjusted R square is a better measure for coefficient determination, that is represented as R square. So, let's try to understand how adjusted R square works. So, let's first run a regression, and I actually have run the regression. So, you have to trust me on this. I used national sample survey data where I took my dependent variable as wage and my independent variable as general education. And what I found is that I have R square value is 0.0705, whereas my adjusted R square value is 0.0704, all right, and I keep on increasing, and basically what the first thing is slightly adjusted R square is slightly less than the R squared value, and again I add another variable here. So, this is called sector. Sector means rural urban. I have included a dummy variable. We will explain what is dummy variable later on. Here again I see my adjusted R square is slightly less than my R square, and I keep on adding different variables, and I see that the adjusted R square remains slightly less than the R square. It is actually even, the R square value is increasing, but the adjusted R square value is, it is also increasing, but the difference is increasing at the same time. So, adjusted R square is lesser than just R square. Okay. Here what you see. Now, what exactly is adjusted R squares, and that is what we are going to explain here in this lecture. So, when I talk about the regression equation, and we talk about the different variables we include in a regression equation. So, what happens is that as I include the number of regression, the independent variables in the regression equation, I would actually see my R square value to increase, and precisely that is what we have seen. All the different variables I have included, the R square value is actually increasing. So, there might be a case that all the variables are important in explaining the R square, but there might also be a case that the variables are actually irrelevant in the model and it is not actually explaining our R square. Now, what happens if the second is true, when I have included explanatory variables which are not really relevant to my model, but still because of their presence my R square value would increase. And the reason is sometimes what happens is there are so many different variations in the data that could somehow be captured by a variable which is actually irrelevant to the model, and that is because of that, as you keep on increasing the explanatory variable, your R square value will increase, but you do not want that. So, what you want is to kind of penalize if the number of explanatory variable increases in your model. So, what we do is we actually use this formula is equal to 1 minus R square into n minus 1 by n minus k minus 1, where n is the number of observation and k is the number of explanatory variables. K is the number of explanatory variables. So, what is happening here? So, if I actually increase my k, what will happen is that my denominator here will reduce, right. So, increase in k means the denominator, let us say it is d, the d will reduce, and that means the whole term here will increase, right. The whole term here will increase, and which would mean if I subtract it from 1, the adjusted R square is actually going to decrease, right. So, you can see how the change in value of k, which is my number of explanatory variable, or increase in the number of explanatory variable, is actually going to influence my adjusted R square, right. So, this is how we actually include this penalty term to kind of ensure that adding more variables is also getting penalized. Now, if I add more variables, I can clearly see that it is getting penalized, but suppose my variables are actually helpful in explaining the model. So, what will happen? Just what you have seen, the R square value will keep on increasing, right. R square value will keep on increasing because it might be that your variable is actually relevant to your model and R square is increasing. So, if it does, then what will happen is that your, of course, there will be a penalty term because of the k, but then your R square value is actually increasing. So, what will happen, the whole value, adjusted R square value will increase also because of the original R square value. So, if I keep on adding the relevant variables, because the R square value is increasing, despite the fact that I am offsetting with this k, my adjusted R square value will also increasing. So, that is what I mean to say here is that the adjusted R square value is accounting for the penalty due to additional variables, but at the same time, if my model explanatory power of my model is increasing, that is also being reflected by my adjusted R square. So, let us write it down. So, two things here. It reflects the explanatory power of the model, and at the same time it takes into account the penalty due to additional or irrelevant variables. So, this is how we should understand the role of adjusted R square in explaining a regression table. So, thank you.